probability density function. What are probability density function? So it's the same thing. It's for the continuous. It's for continuous random variable. We have seen this. Continuous random variable. Whenever we have continuous random variable, we get the probability density function. Okay. Also, we know that when we have a continuous random variable, right, probability at any given point is 0. You cannot, even if on the line segment, right, if I have 1 to 2, probability at any given point, just one single point, this is 0. At any given point, this is equal to 0. But we can find the probability for a given range. If I have this range, okay, for example, this is a 1.6. So I can find the probability of finding any number between 1.6 to 2. This is defined. But probability of finding 1.6, this is 0. Okay, I hope that is clear. We have discussed this earlier also in the discrete and random in the continuous events when we are talking about. So probability of finding, probability at any given point. At any given point, x is equal to, at any given point is equal to 0. Any exact value, okay, at one point is 0 because there are infinitely many such points. So probability at given point is 0. So it does not give any absolute value at any given point. Like in PMF, we got the absolute value at given points, right? Here we get the probability of a given range because at any given point it is not defined because it is so small. Out of infinite values, you want to get the probability of 1 point, it's impossible. That is like kind of 0. Okay, that's what it means. So here what we do, we get the probability over a, okay, instead of a value, we get it probability over a range. Okay, and why is it called density? So now from here you can see here, right? So we, in a given range, sorry, if you see, this is if you know what is a normal distribution, the density of values or the density is high near the mean. This is your mean, mu. So the probability of finding any value near the mean or the average value is very high. So the density is high here, and that's why you can see this has gone up. And probability of finding any value away from the mean is very low. That's why you are seeing that the density has gone down. So this curve is your Gaussian PDF. So here at around the mean is your mu. The density is very high. It's with very high probability we can find number if you are like arranging people with some height, right? And this is the average height of India. Then we can find people, the probability of finding people with 165 centimeter height is very high. So that's why the density is very high here. But as we go towards very small, like 100 centimeter or like 200 centimeter, the value, the probability of finding someone with such a large height is very low. Okay, so that's why this density function tapers down, and this is the value there, that it is very low. So this gives you the density. That's why it's called density, probability density function. Okay, here it is spread out as we have in liquid, right? A liquid, if you have a volume of liquid, finding, okay, what will be the weight of any liquid at a given point, that is like very small, it will be 0. That's why we don't talk about mass at a point in a liquid or any fluid, or you like make a solid into powder. It will be each point will become very small. The value or mass of that will be very low. But if you lump it together, we can like it will become a mass. That was 1 unit, and we like make it a powder. Now we can talk about its density, how dense that powder is at a given point. So the probability of finding that material in that dense region will be higher than a region which is having less density. I hope that is clear. That's why we talk about density in terms of continuous variables, continuous random variables. Okay. Now, what are some key properties? The same properties will come here also. Key properties or key points. Let's go through that. What is the first point? Again, the function, the probability density function should be non-negative everywhere. Non-negative everywhere. We cannot have negative probability, right? So that's the thing. So f of x, it's denoted by small x, is greater than or equal to 0 for all x. This is how it is defined. The second point is again similar to what we have had in PMF. Second point is sum of all probabilities is equal to 1. Here also sum of all probabilities is, so here how do? You do sum of individual values. Here since you have a plot of graph, so this will be area under curve, total area in this, like for this, the total area under this curve, like this area will be equal to 1. Total area under curve is equal to 1. That is my total probability. It cannot be more than 1, right? And should not be less than 1 also. This is the region where I will find all the probabilities. If I sum from whatever probability, the lowest probability to the highest probability, the total sum should be, if I sum it from minus infinity to infinity, f of x dx, this will give me 1. So again, about integration and differentiation, all these things I will create another video. Put the link in the description. And the third point is that for if I want to find what is the probability in a given range, so probability in a given range a to b, how will we define it? This will be equal to the integral a to b of x dx. This is how we find in the range of values. Okay, this will be like, if you break it down, right, this will be equal to minus infinity to b. What is the for 1 point, what was the value for 1 point? How did we define the PDF? At any given point, what was the PDF? So this will be there, this holds. Okay, for any, at any given point, it's till any given point, probability less than, okay, probability of x less than or equal to, x is equal to minus infinity to x. We have seen this during CDF. Okay, is equal to f of x. We saw this in the CDF, right, from minus infinity to x. So how will we using this? This will be minus infinity to b, because b is the upper limit, and f of x dx minus infinity to a f of x dx. So if you understand here, right, so let me plot a graph so that you understand. So let me plot a graph. So say for example, this is my curve, some random curve. So what will be the total area under this curve? This area will definitely be equal to 1, because this is a PDF. I'm telling you, this is a PDF. This is your x. Okay, this is my PDF. It's my probability. My PDF. Okay. So this is my area. So if I want to find the area under curve, say for example from A, sorry, this is a point A, this is a point B, this is B, this is A. If I want to find what is the value or the probability of finding any value in this range, okay, so I want to find the value like anything less than or equal to this, so I can use my CDF formula. This is my CDF for finding anything less than or equal to x, less than or equal to b will be minus infinity to b. For finding anything less than a will be minus infinity to a. So if I subtract this minus infinity to b, minus infinity to a. What will be the remaining part? Will be my required sum, required probability area, the area under this curve, right? And this is what we got, that this is your integral from a to b. This is your probability in a given range. Okay, I hope this is clear, that what did we mean by this. Okay, so now let's use the other example also what we did earlier and understand that. So for example, our this omega was defined in the older example. Omega was defined in sample space was defined between 0 to 2. We had this line number 0, 1, 2, right? And x of omega was defined as omega. So what was my PDF? F of x is equal to differential. If I differentiate it, so if I integrate, where is it? You saw here in CDF, right? So if I'm integrating my PDF, to get my CDF, so differentiating it will give me the CDF will give back my PDF, because differential is a reverse of integral, both are reverse of each other. So using the same thing, what will be the differential of, how was my function defined? F of x, right? So this was defined as, let me show you, where did we do that example for the continuous case. We did that number line example, right? This one. This one. This is how our function was defined. X by 2 for between 0 to 2. So what will be the differential of x by 2? This will be half. Otherwise these are constant, this will become 0. So only the PDF will be there in this, probability density function will be valid in this range, because that's where my complete function is defined. Other places it's constant, so my differential of this will be 0. So what will be my f of x? Where is this? So this is equal to, now what will be my this is equal to half for 0 is less than x equal to 2 in this region. Otherwise it will be 0, because those are constant. And so how will my PDF look here like? If I draw my PDF, 0. And let me say this is half. So so this whole thing, so from 0 to 2, this will be half. This is my differential of that, x by 2. And this whole region, this whole area, what will be this area? This complete area, this area will be equal to 1. And you can see from the calculation also, it's a rectangle, length into breadth, half into 2, this is equal to 1. So this is my 1. So area under the curve will be 1. So from here you can see this, that area is 1. This is your x, and this is my PDF, the probability density function. This is the probability. This gives me my probability, half. Okay, and these are the values for x. At x equal to, from 0 to half, this will be, wherever it will be, this will be x by 2, half. Okay, so I think this should sum up or give you understanding of the PDF also. And as I mentioned earlier, both of this PDF and PMF, these are just giving me the distributions. Okay, distributions of probability, both of them, both PMF and PDF. This is for discrete, this is for continuous. So generally these are also called, so I'll write here probability. So this is probability distribution function. So both are in general called probability distribution function. Okay, and for the discrete random variables, it's called probability mass function because the values are concentrated at different masses. And for continuous case, it's called probability density function because we have a density at a given range of values. Okay, it's not defined at particular concrete masses. So this is the overall picture of what is a PDF, PMF. Okay.